So basically what we're going to tackle then is try and develop this spreadsheet a little bit further and look at, I think I'll go with looking at the sensitivity of the American euro put price to changes in sigma. So what's the effect on the American option and the European option? Again, we'll look at the call and put, but what is the effect of changing volatility? Now, typically, if we look at this relationship, if we increase the volatility, right? If we increase the volatility, the value of the call goes up, the value of the put, the American call goes up, the European call goes up, the value of the European put, American call, European call all go up in turn, okay? So how might we do that? Okay, so we could actually take this previous worksheet and just very simply insert, move or copy, and we'll say C versus T, create a copy. Right now, that means if you copy and paste, then the graphs always are linked back to the previous worksheet. But if you copy the way I've just done, then the graphs here are sympathetic. I mean, they are based on the figures in the spreadsheet, right? So everything is live, okay? We just have to set up volatility. So just be clear, we're going to repurpose this table so that's a volatility table. So I can put in here sigma as opposed to T. It's currently T I've set up, but I'm going to make it a sigma value. Now the sigma values are different to, it's not unusual to get a 2-year option. It's not normal either, but it's not impossible. So we need to set out maybe different values, not 2. 2 would be 200% if we're calling this sigma. So I'd say maybe we should say, 10%, 20, 30, and so on, and just pull those along, right? Now in our spreadsheet, in our parallel framework, just across here, we've the same thing going on, right? So I've basically set up the same basic structure that we had previously, and I've built a spreadsheet. So basically what we've done here is I've deleted out, let's delete the whole table. And what's below? So that'll delete out, that's not a problem. And again, what I'm doing is I'm setting this cell equal to where we estimated the Lysen-Reimer binomial tree. And we can then say American call or European call, or we can say it's a put or American put, just by changing those letters there. So if you recall, the cells here are referenced, and they each have, they represent arguments or parameter inputs for the Lysen-Reimer model. And again, if we took values that were more familiar with, 20% volatility, 25 steps, it's American, it's a put. Okay, let's make it a call. And let's make the dividend equal to, remember we're using B here, cost of carry. So if I change B to 5%, that means Q would have been 0, right? And we get here the familiar value of 1045. And then if I change that to E, it won't make any difference because it's not optimal to exercise an American option early. it's not optimal to exercise an American option early if we've no dividend yield. Okay, and okay, so we've 1045 here. If we change this to be a put, right? If we change this to be a put, we get that familiar 557. So that's looking quite good. And we also know if it's American, it is optimal to exercise early. So we'll get a slightly higher value for the put, right? 607 for the American style. But we're going to work initially here looking at, we'll just go with European and call, right? And then we'll consider the effect. Now, again, I want to judge what the effect of volatility is. If we increase volatility, can we verify what's going on in the table here? Okay, so we want to see, can we increase, if volatility goes up, do each of these go up? That's what we want to show. Just the American call, European call, European call, European put, American call, American put. Did they increase as we increase volatility, decrease as we decrease volatility? Okay, that's just the basic thing I want to inspect. Now, to set up the data table, we'll just take the two-dimensional table. We go data, tab, what if analysis, data table, and we have two inputs. The row here is obviously the volatility. This is the sigma, V is the sigma, and then on the column, we're considering different stock prices. Okay, so we'll put in that 100 and we run. And then the values here that appear are parallel to the values I have across. So you see this cell was set equal to this one, this cell below, the same. And we have a complete set of tables now. Okay, we looked at this before, but it might be, let's put in a chart here. It's easy to graph. If the apex cell is missing, if we have volatility on this axis and the stock prices on this axis, we just go into insert, scatter graph. Let's use this one. Could we do better? Okay, and then let's have the legends at least incorporated in, legends, and they're underneath. That's grand. Okay, so it's kind of clear if we increase the volatility here, right? If we increase the volatility, the value of the option is going up. So we go from this dark navy, slightly brighter blue to a darker, to orange, to gray, all the way up to red. And we can see in each instance for the European call option, increased volatility, right, we're increasing the value of the option. Again, we can take these over just to compare and put on the screen so that we have everything together so that we can observe a little bit more directly. But can we show that as we increase the volatility, we're getting a set of relationships consistent with what's being portrayed in the graph? So for the European call option, and we have a European call option, increase the volatility. These are volatility figures, the value of the option goes up. What if we change that to A? Okay, there's no change, but that's because the dividend is 0. What if we change the dividend to 5%? Okay, by making B 0, it means the dividend is 5%. You can see here, okay, no change. Right, even if we can exercise early, the increasing the volatility right? For a European call option and an American call option, you increase the value of the option. If you increase the volatility, both European call and European call and American call go up in value. Reduce the volatility, the value of the option drops. Okay, so that's quite straightforward. What about for a European put? P. Okay, same thing. If we increase the volatility, the value of the option goes up. This is the this is the Lysen-Reimer parabolas generated by using different levels of volatility, different stock prices. And you can see we've different parabolas. As we increase the value of the volatility for the European puts, the value is positive, right? We increase the volatility, the value of the European put goes up. If it's American, any change in that? Some change in valuation, but the same general pattern emerges. Increase the volatility, right? If we increase the volatility, the value of the option is going up, right? Always goes up, goes from that low, that blue, up to the red. I mean, we can make it clearer if we select data and then we just remove intermediates, right? Just the remove, right? If we get obviously much more evident, go from 10% to 80% volatility, the value of the put here, American put goes up. It's true for the European put, same relationship. What about the European call? It's true, increase the volatility, the value of the option goes up. What about if it's American? Any change in that? No, always the same. So it's a straightforward positive relationship here we're mapping out between the volatility in each of these option specifications. Okay, the next thing then is to look at interest rates. Now, I better rename that graph, right? So this is, just to be clear, it's the value of the option relative to the value of sigma, and sigma being volatility, okay? Next thing we would like to do is consider, look at different interest rates, right? So we can, maybe we'll build it from scratch, right? Or not. Okay, maybe I'll move the entire, so CS, create a copy of that. And the virtue of making a copy is that everything then in here is live. Each of the graphs that we have is based on, you know, figures we've generated internally in this worksheet. Otherwise, if you do a copy and paste of a worksheet to another worksheet, the graphs you paste over are linked to the previous worksheet. That's a problem. You want graphs that are responsive, that change as you change your figures in the worksheet. So that's the advantage of move or copy here when we look for move or copy. That's why we use that option. Okay, now we're saying, what about the interest rate? Can we observe the effect of changing the interest rate, right? Okay, now U is equal to, let's copy that, copy, and escape, insert. Okay, so we're going to have Q is equal to, and then paste. Okay, so what I need to do here is isolate the effect of R, isolate the effect of B. I want to observe the value of the option relative to a change in R. If I change R, I change Q. So that's not satisfactory if I limit B to 0 here. Okay, so the best approach would be to isolate R. We'll take these values and just drag across. Right, and then you can see that we can look at the just changing the interest rate, right? So if we change, let's go with an interest rate of 1, interest rate of 2, interest rate of 3, interest rate of 4%, and go all the way up to let's say 8-9%. Can go all the way 13%. Right, now our problem here is that as we change, looking at the data that's here, right, looking at the data that we have here, as we change R, we're changing Q, right? So we want Q to remain the same. Okay, so the only way we can change Q is to change, let B adjust so that Q is 0, right? So remember, Q is equal to R minus B. So if we change it to 0.01, right? Okay, so we have if R is equal to 1, and then we go to 2 and 3, we saw we're changing the dividend in tandem. So the only way to adjust for that is to ensure that Q stays at 1%. Okay, so we have to adjust B here so that as R goes up, that the dividend is locked at 1%. Okay, so that's it. Now we could do it in another way. Maybe we need to consider negative 0.04, right, and negative 0.03, and you see I'm going to lock the dividend at 5%. Okay, so the dividend is constant. So I have to adjust B when I adjust R in order that I lock the dividend at 5%. Okay, so can we then graph the relationship between the interest rate and the value of the instrument? So this is European call. Okay, yes, data, what if analysis, data table, on the, so insert, scatter, we'll put in a scatter graph, select data, remove everything that's there. It's just 2 we want to compare together, and that is add, and it's C, or option value, versus R. Okay, so we're going to look at, on the horizontal axis, we're going to consider different R, going from 0 to 13%. And then on the vertical axis, we're going to have the 594 all the way up to 1115. Okay, and what do we observe in this graph? As we increase the interest rate, let's bring up maybe our, as we increase the interest rate, does the value, so as we increase the interest rate, does the value of the call option go up? It does. Is that true for the American option? Okay, let's try the American option A. Right, it's true for the American option. What about if it's a put? for the put. Okay, so one final thing here then is that this must be equal to this and drag across. And then this must be equal to this cell and we'll drag across. Okay, so if I change to E and C, that's the original graph that I have. Okay, so it says here, if we increase the interest rate, the value of the option goes up. Okay, we find that for the European option. What if we change it to a European put? Okay, European put, it says it should be negative. Okay, we get a negative relationship for the European put. If the interest rate rises, we find that the European put goes down in value, right? If the option is American, okay, so let's go back to the call and change it to American. Okay, it's still positive. So for the interest rate, it's a positive American call. And interest rates, if we increase the interest rate, the American call goes up. And we're predicting for the American put, increase interest rates, the value of the put goes down. So change this to P. And we get the same overall effect, right? Okay, so that's the option value versus the interest rate. Okay, let's now go back and examine what's the effect of changing the dividend, with respect to the value of the European and American call and put. Okay, so it might make sense to move or copy this particular one and tick the box here, create a copy, and it's C versus the dividend, right? So we'll say Q, and then just put in. Okay, now in that instance, okay, here we changed we looked at the dividend, right? But now we need to ensure that the dividend goes up. So this time we're going to go back to the situation of the interest rate being 5% and dragging across, right? And I want to see the dividend then go from go up. So here we see it going down. So if I reverse the order of the variable 0.08, okay, we'll try that 0.08, 0.08, 0.07. Okay, we got to start with 0.05, 0.05, 0.04, 0. Okay, and drag across, right? And that's the only way we can engineer our interest rates that the dividend is going up here. So we go from a dividend of 0 to 1, 2, 3, 4, 5, 6, all the way up to 12. But I got to reverse engineer it. And if we look at our numbers here, let's delete our graph for a moment and just build it from scratch. We would say insert scatter graph. We can use this as our template. Select data, remove whatever's there, add. Then what are we considering? We're comparing the C versus, or the option value, let's say option value versus VSQ. And on the x-axis, we have the different dividend. So we'll come down here and go from 0 all the way up to 12%. And then on the vertical axis, we have the value of the option given here. Okay, now what do we observe? We observe that this is for the put. Let's have a look at the European call to start off with. Okay, if we increase the amount of dividend, the value of the call falls. What if this is a put? P. If we increase the dividend, the value of the put goes up. What if it's an American call? So change the specification to A and then to C. If it's an American call, the value of the option is negative. As the dividends increase, the value of the call is falling. The American call falls. If it's an American put, the value of the American put goes up. If we increase the dividend, the value of the American put. So the results that we were investigating in terms of, if you go back to the original question, the sensitivity of the American and European call price to changes in dividend rates relative to Q, what we observe is that if it's an American call and European call, right, if we increase the dividend, the value of the option falls. If it's a European put, right, if it's a European call, and we just look at call again, for European, it's a negative. For American call, it's also negative. This relationship with the dividend. Increase the dividend, the value of the call is clearly falling, both for the European and the American styled options. Change it to put, we of course reverse that for both, right, European and American, right? Small differences might occur, but still the general trend is there. For the interest rate, it's the same, except we reverse the signs, right? For European call, if you increase the interest rate for the European call, the value goes up. If you increase the interest rate for the European put, right? If you increase the interest rates, the value of the option goes down. If you increase the interest rates, the value of the European put goes down. For the American call, you increase interest rates, the value of the American call goes up. Increase interest rates, the American call goes up. If we change this to American put, the value goes down. Increase the interest rate, the value of the American put goes down. Okay, so that's basically a summary then, how we would represent or show that these relationships hold. We can use Lysen-Reimer, and it's very effective in doing that. Okay, so that's something worth considering then when we're mapping out